Today we are going to be talking about applying the fundamental theorem of algebra. There's a couple of things that you need to keep in mind when you're applying the fundamental theorem of algebra. The first thing is the theorem. It says that when the degree of the polynomial is greater than 0, if the degree is greater than 0, the equation has at least one solution in the set of complex numbers. Alright, that brings back when we talk about complex numbers. A complex number has to do with I, which is, complex number is an I, which is actually equal to the square root of a negative 1. Alright, so at least one solution will be in the set of a complex number. So that can mean that it's 1 plus I or 1 minus I as a solution. It also says that the solution can be repeated. Alright, so the solution of the equation can be repeated. And in some books, when it says repeated, in some books they will call it a multiplicity. What that means is if they tell us that we have 5 answers, because that's what the degree says, but the only number they give us is 1, then that means that the multiplicity of 1 was 5 times. That means your answer was 1 5 times. So that is these two things, the degree greater than 0, the equation is going to have at least one set of a complex number, and then again the solution of the equation can be repeated. It can say repeated, or it can say a multiplicity. The next thing that I want to do is use this by finding the solutions. We want to find the solutions of the zeros. Alright, to find how many. Find how many solutions for the polynomial equation. Alright, so in this one, my example is going to be a negative 6x to the 4th plus 7x squared minus 15. Now we have previously talked about how our degree, which is the 4th degree, our degree will tell us how many solutions there are. So when we look at this and it says find how many solutions for this particular polynomial equation, you look at the highest degree, which is to the 4th power, and so we will have 4 solutions. For this particular equation. The next concept we are going to do is find the zeros of the polynomial equation. For this concept, I chose to use f of x equals x to the 5th minus x to the 4th minus 7x cubed plus 11x squared plus 16x minus 20. The first thing we need to do is to find the factors of the last number, which are 1 times 20, 2 times 10, and 4 times 5. And the factors of the first number, which is an understood 1, so it's 1 times 1. So we can find the possible rational zeros. Again, all possible rational zeros can be a positive or a negative of the numbers of the last factors over the first factors. And so I can see that my possible rationals are 1, a positive or negative 2, positive or negative 4, positive or negative 5, positive or negative 10, and a positive or negative 20. From here, you want to set up synthetic division, which means we're going to draw our upside down division box. I want to put my numbers. I've got my 1, my negative 1, a negative 7, a positive 11, a positive 16, and a negative 20. What we have to do at this point is choose one of my possible rational zeros to divide out. And by choosing, we want to choose one that will get us to making the negative 20 cancel out, which means add 20 to make it a 0. That is our goal. What I like to do is I like to use my smaller numbers first, and so that's what I'm going to do now. I'm going to choose to use 1. Remember, we always bring down the first coefficient. So we have 1 times 1 gives me 1. A negative 1 plus 1 gives me 0. 1 times 0 gives me 0. A negative 7 plus 0 gives me a negative 7. 1 times a negative 7 gives me a negative 7. 11 plus a negative 7 gives me 4. 1 times 4 gives me 4. 16 plus 4 gives me 20. 1 times 20 gives me 20. A negative 20 plus 20 gives me 0. So the first one I chose happened to get the correct 0 at the end. So therefore this one is a 0 of this function. From here, we want to keep going down. And what I do is I just keep my synthetic division box going. And you know, you're going to bring down the first one. Now again, I want to choose any of the possible rationals, any of these right here. What I'm going to choose to do is a negative 2. A negative 2 times 1 gives me a negative 2. 0 minus 2 gives me a negative 2. A negative 2 times a negative 2 gives me a positive 4. A negative 7 plus 4 gives me a negative 3. A negative 2 times a negative 3 gives me a positive 6. 4 plus 6 gives me 10. A negative 2 times a positive 10 gives me a negative 20. 20 minus 20 gives me 0. So again, I have found a 0 of my polynomial equation right here. I still want to keep going down. And again, we bring down our first number, which is our 1. This time, I think I'm going to use a negative 2 again. Alright, so I'm going to go ahead and put a negative 2. Now keep in mind that the fundamental theorem of algebra said that you can have a solution that repeats. And so just because I used -2 once doesn't mean that it can't be used again. That's why I want to see if it'll work. So a -2 times 1 gives me a -2. A -2 plus a -2 gives me a -4. A -2 times a -4 gives me a +8. A -3 plus 8 gives me 5. A -2 times 5 gives me a -10. 10 minus 10 gives me 0. So again, I have found another 0. At this point, what I'm going to do is I'm going to change over from synthetic division to the quadratic formula, because I can see now that I have my A, B, and C for the quadratic formula. So over here, I have my A equals 1, my B equals a -4, and my C equals 5. Remember that the quadratic formula is a -b plus or minus the square root of b squared minus 4ac all over 2a. So at this point, I'm going to go ahead and replace my a's and b's and c's with the numbers that I have. And so I have a -4 plus or minus the square root of a -4 squared minus 4 times 1 times 5 all over 2 times 1. A minus a -4 gives me a +4 plus or minus the square root of a -4 squared, which is 16, and then a -4 times 1 gives me a -4, and a -4 times 5 gives me a -20, and then all over 2. At this point, I'm going to do my math within my radical sign. So I have 4 plus or minus the square root of 16 minus 20 gives me a -4 over 2. I cannot have a negative inside of a radical sign. The way to move that negative is to replace it with an I. So I'm going to do that. I have 4 plus or minus I square root 4 over 2. Now, I can see that the square root of 4 is 2. And so, again, I can rewrite, and I can say 4 over 2 plus or minus 2i over 2, which when reduced down gives you 2 plus I, 2 plus or minus I. So this right here is 2 answers. So altogether, I have now found that my zeros are 1, -2, -2, 2 plus I, and 2 minus I. So we started the equation, we started working the equation using synthetic division all the way down until I've got 3 answers on the bottom of my synthetic division. Those 3 answers are my A, B, and C. From here, I came over and I used the quadratic formula to solve for my last 2 answers. I plugged in my A, B, and C, and I went ahead and did the basic math, came down, and what we have to remember is that a -4 becomes an I square root 4, and then the square root of 4 is 2. So when we reduce this down, it becomes 2 plus or minus I, which means you can have 2 plus I as a 0 and 2 minus I as a 0. That is how you find the zeros of the polynomial equation. The next concept that we are going to look at in applying the fundamental theorem of Algebra Lesson is concerning complex conjugates and irrational conjugates. A complex conjugate will have an I. Anytime you see the word complex, you will have an imaginary number. The conjugate means that if you have A plus BI, the conjugate of it is A minus BI. You're going to have the opposite also. So if you have a positive, the opposite is the negative. With the irrational conjugates, again, irrational lets you know that you're going to have a square root, which is a radical sign. All right, so the conjugate is, again, if you have a positive, A plus square root B, you will also have the negative, A minus square root B. So those are what the conjugates look like. Again, if you see 1, if one of the conjugates is a 0, then the opposite, the conjugate of it, has to be a 0 also. So what we're going to do is use the zeros to write a polynomial equation. The example that I have says write a polynomial function that has rational coefficient, a leading coefficient of 1 and 4 and 1 plus square root of 2 as zeros. The first thing that I notice is this 1 plus square root 2 is a 0. That is an irrational conjugate. So therefore, if I have 1 plus square root 2, I'm also going to have 1 minus square root 2 as a 0. Remember back to one of the previous lessons where we talked about changing from a 0 of an equation to a factor of an equation. When you change it to a factor, whatever you have right here, which is a positive 4, when you put it into factor mode, we have x minus 4. Again, we have a positive 1 plus square root 2 because this is an understood 1 term. And this is an understood 1 term. And so since they are both positive, again, when we put it into the parentheses for factors, we have to say x minus 1 plus square root 2 and x minus 1 minus square root 2. From here, we want to start multiplying them, but I can look at both of these. I can look at our conjugates, and I can see that if I rewrite them using the associative property, it might make it easier. So that's what I'm going to do now. I'm going to say x minus 4 because that does not change. I'm going to do a bracket this time, and because of the associative property, I can go ahead and say, okay, well, since this is addition and subtraction, I can rewrite where x minus 1 is together. So I'm going to do that, x minus 1, and then that leaves me with my, when I go to put this into the, you have to distribute the negative to the positive. So now I have minus square root 2. And so that's the end of the first bracket. I'm going to start a new bracket. And again, right here, I can go ahead and associate it differently and still say x minus 1. But this time a minus times a negative becomes a positive square root 2. Now I have it rewritten to where I can see that I have x minus 1 and an x minus 1 twice. So what I can do is say x minus 4, and again I want to keep my brackets for right now, but I'm going to go ahead and put x minus 1 squared. I'm going to put both of these into one set term with a power. So x minus 1 squared. Then I have a negative times a positive still gives me a negative. And then how many square root 2's do I have? I have 2. So I can say square root 2 squared. And I'm going to put this in a parentheses also. Now, my bracket can close. Now, when you see this, we know that x minus 1 squared means I can rewrite and say x minus 1 times x minus 1, and then minus square root of 2 squared. A square root cancels out a squared. And so we just have minus 2. And then again, bring down my x minus 4. Now I'm going to FOIL my x minus 1 and x minus 1. So I have x squared, because x times x. X times a negative 1 is minus 1x. A negative 1 times x gives me a negative 1x. And a negative 1 times a negative 1 gives me a positive 1. And then I have my minus 2. Now I can go ahead and have one parenthesis there and my one parenthesis here. Again, I want to combine like terms. I have a negative 1x and a negative 1x, which gives me a negative 2x. A positive 1 minus 2 is a minus 1. And I just bring down my x squared. And then I bring down my x minus 4. At this point, I'm going to go ahead and I'm going to move over here. And I'm going to rewrite. I have x minus 4 times x squared minus 2x minus 1. What I'm going to do here is I'm going to set it up as a distribution. So I'm going to say x times x squared minus 2x minus 1. Then my minus 4 times x squared minus 2x minus 1. From here, I can multiply. I distribute my x to everything in parentheses. So x times x squared. Remember, that means adding the exponents. So that's x cubed. X times a negative 2x is a negative 2x squared. Again, because we added the x's. X to the first and x to the second. And then minus x times a negative 1 is a negative 1x. So minus 1x. Then we're going to move to this set. And I'm going to do a negative 4 times x squared is a negative 4x squared. A negative 4 times a negative 2x is a positive 8x. A negative 4 times a negative 1 gives me a positive 4. At this point, what we have left is to combine like terms. I can see that I have 1x cubed. I can see that I have a negative 2x squared minus 4x squared, so that gives me a negative 6x squared. I have a negative 1x plus 8x gives me a positive 7x, and then a negative, and then all that's left is just my 4, which is plus 4. And there is the equation that we get when we have a leading coefficient of 1. Remember, just x cubed means 1x cubed, and 4 and 1 plus square root of 2 and 1 minus square root of 2 as your zeros. The last concept we have today is the Descartes rule of signs. In the Descartes rules of signs, what it says is that when you have f of x, every time the operation changes from a positive to a negative back to a positive, every time it changes, you add those changes together. And so for this one, we have from a positive to a negative is 1, and from a negative to a positive is 1. So we have 2 changes. All right? But it also says that you can have these 2 changes or the next lower even number. You can reduce it by an even amount. So this would be 2 or 0. When you're using Descartes' rule of signs, you also have to look at f of a negative x. So in this one right here, this positive, negative, positive, it might change because for every x that's given, you have to make it a negative. So if this was originally a squared, and then the first, say, a positive, and I'll rewrite and say 2x squared minus x plus 3. Alright, so in this, I would put a negative. So I'm going to say 2 times a negative x squared minus a negative x plus 3. Now, for this, what you would do is look at the fact that a negative to the second power would make it a positive. So I would rewrite this as 2x squared, and then a minus times a negative is a positive, so it's plus x plus 3. So for this instance, we have no changes. So again, we would have 0 changes because it's all positive. And if we had had 2 changes again, it would still be 0 or the next even down. But in this case, we don't have negative zeros. And so it would just be 0. So now I have a set example, and I'm going to do f of x equals x to the 4th plus 2x cubed minus x squared plus 3x plus 5. Before I do anything else, I want to go ahead and say f of a negative x equals a negative x to the 4th plus 2 times a negative x cubed minus a negative x squared plus 3 times a negative x plus 5. Keep in mind, like I did up here, when it's a negative to a even power, it becomes a positive. So I can rewrite the negative x to the fourth as x to the fourth. Because this one isn't even, it keeps the negative, and so minus 2x cubed. Again, I have the even power, and so this would become a positive x, but I still have this negative, so minus x squared. Then I have 3 and a negative x, so minus 3x plus 5. At this point, I see all my plus signs and minus signs. So what I want to do is make a table. My table is going to show I have the positive, real zeros, negative, real zeros, imaginary zeros, and this is the total zeros. So the first thing I'm going to do is I'm going to look and count how many times my operations change. In this instance, it's going to be from a positive to a negative. And so for f of x, I have a positive x and a positive 2x, so that doesn't change. But I have a positive 2 to a negative x squared, so that changes once. And then the negative back to a positive changes it again, so that gives us 2. And then positive to a positive stays the same. So we have 2 positive real zeros. And again, we're going to list that twice. We're going to list it twice. That would be. Now, the next thing I want to do, 2 or 0. Remember my 2 or 0. The next one I want to do is my f of a negative x. Again, I started with a positive x, but then it immediately went to a negative 2. So that gives me one change. Then it goes to a negative x, so that's still just the one change. Again, it goes to a negative x. Once again, that's just one change. But then we move to a positive 5. So that means we have 2 changes. So again, we can say 2 or 0. So we're going to put a 2 by my 2 and a 2 by my 0, because each time we have a 2 or a 0. So 2 or 0. And this time we have our 2's or 0's. Now, the next thing we're going to do is look up how many total zeros we're supposed to have. Remember, to know the total zeros, you're going to look at the highest degree, which is 4. So I'm going to come over here, and all my totals are going to be 4. Now, what you have left to do is to find out how many imaginary zeros. You do that by adding up the positive, negative, and imaginary to equal your total. So for the first one, we have 2 plus 2 gives me 4 already, so therefore we have 0 imaginary zeros. The second one, we have 2 positives plus no negatives, that gives me 2. But I need 4, so therefore in this instance there's going to be 2 imaginary zeros. Again, we have 0 positive plus 2 negative, that gives me 2, but I need 4, 4, and so again we'll have 2 imaginary zeros. And then the last one we have 0 positive plus 0 negative, which means all possible zeros, total zeros, will be imaginary. And that is how you use Descartes' rules of sign.